Hello, everyone. Welcome to this amazing workshop um, given by the known 0xEvolve from Pragma Oracle. Um, Welcome on board, OX. Hope we'll have like a great workshop. Maybe as it is our workshop tonight, I can give a small introduction as well, who we are and what we do. So, Pragma Oracle is the leading oracle on StockNet. So we are also leveraging StockNet to push and to publish our data and to spread the data. Hello, Bakarif, to spread the data on StockNet. So you're building on StockNet. So today you will learn how to pull data from our data feed and how to make your DeFi protocol more efficient. Um, and yeah, so I hope that many of you like came as always good idea of new DeFi product, new DeFi protocol leveraging the computational power of StarkNet and ZK rollups. Um, and yeah, so hope yeah, let's wait as well a few minutes to onboard with everyone. Uh, and yeah, like I want to learn as well where are you guys based and how far are you with your project? Did you already start it? Did you already come up with an idea? Are you only solo dev or are you with the team? Um, Feel free to respond in the chat. Yeah. Oh, nice. So it's also Thursday evening for you, Becker. Nice. Hope you have the air conditioner, the AC at your place because like Nancy, isn't it warm? So nice. Yeah. Try to pull your friend in pull your friend
Okay,
in okay, bro. Okay, cool. So
so I
yeah,
guess we can start things. Hello everyone. Hope everyone's doing great. Basically, for this workshop, I will try to show you how you can use Pragma as its best. So the plan is the following. We'll first uh, give a quick recap about how Pragma works. Why is it different from maybe our Oracle solutions you might have used? Then we'll do a quick walkthrough of the documentation. Then we'll dive into a quick template I've put in place such that you can start in a few seconds to use Pragma and write your DeFi protocol. Then we will basically write some code, try to play a bit with the Oracle itself, explain the different methods in practice. Um, then we will finish by talking about computational feeds. What are those and how can you use them to really empower your app and why are they like really important? Okay, so let me share my screen. Mm, Right. So how many are we? Five. It's the evening. I guess it's fine. So anyway, it will be all recorded and published on YouTube, so that will be public knowledge. So that's great. Okay, so let's start off here with the architecture of Pragma itself. Basically, it's quite simple. Everything is on chain. It's just a set of smart contracts that are currently deployed on Starknet and have been deployed for the last more than a year. So it's been running for quite some time. You have these different accounts. So you have a bunch of data providers, both first party and third party, that are publishing data on the network. So they just interact with the Oracle contract, which is like the main entry point for these data providers. And then you, as a protocol, you read the data either directly from the proxy or from some compute engine, which we'll talk at the end of the workshop. But these are like the most powerful primitives that Pragma offers. Okay, so that's fairly straightforward. You can go take a look at these contracts if you really want. But let's jump into what does Pragma gives you out of the box. So the first thing it of course gives you price feeds, basic price feeds of a lot of assets actually. So you will have access to all of these other assets listed right here. So Bitcoin, ETH, Wrap Bitcoin gets Bitcoin, Solana, Avalanche, Doge, SHIB, BNB, ADA, XRP, and Matic. If you need some other assets, we can always add it. So feel free to tell us on the Telegram channel, and it will be a pleasure to add them. We have stable coins as well and some experimental assets. Um, Most of the pairs are basically labeled, quoted in USD, but you can, let's say you need, for instance, ETH Bitcoin, you will see that there are some methods you can use to get that very easily. You won't have to handle all of this hassle. So that's what written here. If you need, for instance, Bitcoin ETH, there are two methods, and we'll see later in the code, but there are two methods you can use: get spot with USD hop and get spot with hops. So those are the two mains. What we mean by hop is just, as name implies, just jumping some assets. So let's say you want, Bitcoin ADA, maybe why not? You can just go Bitcoin USD and then ADA USD, and then it will do the rebasing for you. And of course, the decimals are written here, so you can, so you're not lost. Maybe Edward, if you can put the link of the documentation into the chat, that'd be perfect. All right. So that's pretty much it for the supported assets and basic price feed. The funny thing with Pragma is that you can see in real time the updates happening into the smart contract. So if you look here on StarkScan, you can see that the updates are happening in real time. So people from data providers are calling very regularly the contract and publishing some data. They just send the data, the raw data, which they have signed with their account contract, and that's it. So it's very, very transparent, and you will see with the interface that it's very powerful because you can actually filter the sources. Are there any questions yet? No. All right. So so that's the Cairo book. Again, for people programming, it's like the main resource for Cairo. Very useful if you get lost while coding. Just remember the Cairo books. That's the main resource to go to. Okay, so let's jump right into the template. So I've put in place this template to help you easily start with using Pragma. You just clone the repo and you start fresh with a Pragma template. So let's do exactly this. All right, so it's open. Okay, so I've put in white to hope it's nice to see. So first of all, I hope you have Caro installed by now. If you haven't, again, head to the Caro book and you will find everything you need over there. The repo just uses Protostar and Scarb to handle dependencies such as Alexandria, which Alexandria is the main repo where people are just putting a lot of algorithms, a lot of math things, data structure, and a bunch of things. This could be very interesting to you if you want to use these algorithms on top of financial data, like signed integers. I think that's very useful if you want to do complex math operation. You also have Qubit, is a library written by Influence that helps you basically use fixed point math. It's something we use internally for computational feed, but we'll dive into that a bit later. Okay, So back to the template. Template is very simple. It just have a source folder with a smart contract in it that showcase basic functionalities and some interface. So this interface is really the only thing you need. So if you're going to code, use Pragma, you just copy paste this interface within your code, and that's it. You have everything you need to interact with the currently deployed contracts. So just a quick reminder here, right now in this template and for this hackathon, you will be interacting with the currently deployed Pragma Oracle, which is written in Caro 0. So it's a funny thing. You can interact with Caro 0 contracts from Caro 1 contracts, but still you will need the Caro 1 interface, which we have written for you. So head to the template repo, just copy paste this file, and you're good to go. Okay, so let's go a bit through this interface. What does it? What can we find in it? So when you okay, maybe we'll start with the ABI. I guess that's the best way to show you. Basically, you have a few functions, notably get spot median, get spot median multi, get spot with USD hop, and get spot with hop. So get spot median, as the name says, is the most basic function you can think of. You just give it a pair ID. So the pair ID is the one you will get from the documentation. In supported assets, along each pair, you have its pair ID. If you that was quite useful in Caro 0, but now with Caro 1, you can actually simply put the the string like this, and it will automatically convert the short string to a felt. So don't bother with copy pasting from the documentation. In Caro 1, you can just write the short string like this. Okay, so you have get spot median that gives you the median price from the aggregation of all the data being published. So maybe I can show you here on the website. It will be a bit clearer. So here on the website, you can see in real time the different data sources that are taken into account for each asset and when was the last time updated and these kind of things. So you can see, for instance, for Eve, there is one, two, there is six. We have six data sources right now. So six data sources doesn't mean we don't have a bunch of people using these data sources. Like there are a bunch of data providers that use these data sources, and Skynet is a first-party data provider. So each of these corresponds to some storage on chain. So you can actually filter the sources, and like the aggregation happens on our smart contract itself. So if you want to aggregate the data differently, maybe you don't want to have median aggregation, but you want some VWAP or some TWAP or some moving average, then you can just specify the aggregation mode here. Right now, we only support median and average. But yeah, if you're interested to some other aggregation mode, just let us know. We can either you can add it by yourself, or you can yeah, make a PR to our repo, or we can work on it with you. Yeah, and you will still it's still a pretty interesting small hackathon project to see how you can aggregate this raw data in yeah in a smart way, I would say. Okay, so I think an interesting way to really visualize all of this, because I think it's quite hard at the beginning to visualize. It's to go here in get spot entry. Get spot entry. So let's take the pair ID, for instance, Bitcoin, and we can just put it here in the Explorer on SARScan. And there we go. So we see, okay, that's, I felt it was going to be formatted. It's not. So let's put the pair ID and then the source. So for the source, I recommend this pretty useful tool, Caro Utils. Can put in into the chat. It's a pretty useful tool that will help you do conversion between fetch, or strings, filter, and whatever. So that's no longer really useful in Caro 1 actually, but still, if you're doing low level stuff, can be useful. So let's take, for instance, DeFi Llama as a source. Llama, there we go. Let's come back here and boom. Okay, so we see for each of these things, we give a pair ID and a source, we get an entry. And an entry is made of all these fields. And you can actually play with all these fields on-chain within your smart contract. So for instance, if you don't like DeFi Llama, or you don't trust one of these sources, like you only care about aggregating the price from Coinbase and Skynet, let's say, okay, that's good. Let's write that. So here we're just getting the spot median, but that takes into account all the sources. Let's say we only care about DeFi Llama and Coinbase. Okay, we don't want the other sources for whatever reason. Okay, actually the Explorer. All right. So it will be pretty much the same. So we can just copy that. Then we use the Oracle dispatcher. So if you followed a bit of our workshops before, you will know that when you want to interact with an external contract in Caro 1, you just need to use, you just need this. You just need to use Pragma Oracle dispatcher and the dispatcher trait. These are generated automatically thanks to the ABI macro attribute. We can actually click on it and see like the whole implementation. All of this code is generated for you by the compiler, and it's really very useful. You just need to import those, and that's it. So what we care about here is this function, like get spot for sources, because we want to filter which sources we care about. All right, so get spot for sources. All right. So we can see that it takes an argument pair ID again, and an aggregation mode and some sources. So, all right. So the pair ID, as usual, let's say ETH or Bitcoin USD. Then the aggregation mode. So this 0 is the default. It's median. We could also have put median here, but yeah. The 0 is the default. And then the sources. So that will, you actually need to create an array for this. Okay, sources, we need to create an array, all right? And then we'll need to append some sources to this array. So I cannot wait that we have some more, let's say, friendly syntax to define arrays in Caro 1, but for now, that's how we have to do it. So append, and as we said, we care about DeFi Llama and Coinbase. Okay, so that's perfect. We have our array. We can simply put it here, and that's it. We will now, this function will now fetch the, will now return the spot info, but it will only aggregate the data from DeFi Llama and Coinbase. Whereas here, it was doing the median computation, taking into account all the sources. So of course, here and here, we have two different prices. And I guess that's, yeah, that's very important if you're going to use this function. Okay, so when you have fetched the price, whatever in whatever fashion you want, you need to take into account the decimals. Let's go back to StarScan. You can see here that for Bitcoin USD, it gives us the price with 8 decimals. Of course, in your DeFi protocol, you might, yeah, you might just want to use the price as is. So, yeah, just remove the decimal, a pretty useful thing for this is using Alexandria math. So Alexandria comes with a few power functions. So by default, Caro 1 does not have like a power operator like double stars, but you can use POW or FPOW from Alexandria, and that's it. So if you want to add Alexandria to your repo, simply use carb add Alexandria math, and you can use the Git link here. Okay, so that's pretty much it. And then we can do things like we can have some threshold that we want to make sure the price is above or below that threshold to like trigger liquidations, or yeah, anything you really want. Be creative there. When you have access to the price data, you can, yeah, just do anything. Okay, so let's maybe showcase other functions. Let's go back to the interface. So right now you have access to two types of data, mainly spot data. So the spot data will return you the price and the volume. You also have access to future data. So future data, we mean the data from a perp, I mean not perp, but a future contract that expire not currently live yet, but if you need future data, just let us know and we can add them. And we even have some generic data. So if you need some weather data or some more, I would say, esoteric type of data, let us know as well. And yeah, just send us the API basically, and we can add it to different nodes publishing data, and that's it. Okay, so yeah, if you want to do maybe some more granular operations, you can directly fetch the spot entry instead of fetching like the aggregation. Yeah, so for that we have get spot entry functions or get future entry. Yeah, you can just use those. Okay, and the last thing we're going to talk about are computational feeds. I think that the most important and the most impressive thing about Pragma are computational feeds. So let's talk about realized volatility. So if you're building any protocol like option protocol um, or maybe, I don't know, AMMs or lending protocols, realized volatility is a very useful data feed for you. Like if you want to maybe some have some parameters of your DeFi protocol that are dynamic based on the volatility, then you can use that. So how is realized volatility computed? If you want to learn more and dive deeper in how it's computed, just head to our documentation. So I'll put the link over there. Here. And okay, so here is how the realized volatility is computed. Basically, realized volatility is just there are some checkpoints, so anyone can trigger at any time a function on our smart contract called set checkpoint. So here, set checkpoint, and that will just, as the name says, set a checkpoint on smart contract. So save the data of this data feed at this type sum you're calling it, and save it for later use. And then the realized volatility uses all this historical data to compute the volatility following this formula. So it's actually, this is really the kind of thing you can do on Starknet and you just cannot do before. And we really want you to think about these computations that like TradeFi has been running on for years, like where we will soon have implied volatility ready, but we also have an on-chain yield curve. So you can again look at the documentation if you want to use the yield curve to do like fixed rate interest If you want to do maybe more complex things, we're able to generate that yield curve on chain in Caro in a provable way, which is very important for us. Let's see how we can use volatility. So here is like an example. Again, it's in Caro 0. We're writing the whole Pragma protocol in Caro 1. I will show at the end of the workshop a bit of sneak peek of what's coming. It's going to be way, way better than what is exists right now, but it takes a lot of time because we have a bunch of protocols running with the current Oracle. So we cannot just migrate like that right away. Okay, so realize volatility, it will return a failed. So we have another contract called summary stats that is deployed here actually. So let's go see it. Right here, there it is. Okay, so this contract deployed has two functions: calculate mean and calculate volatility. So it takes three parameters, a key. So the key is just which volatility you care about. So like which data feed you care about. So the volatility of ETH or Bitcoin or whatever. So for us, let's just compute the realized volatility of ETH. Then we need to fetch this address. So we will need to do what we do in the initializer here. So declare an Oracle dispatcher, and instead of reading it from the storage, we will just put the hard-coded version. All right, so this is the testnet one. We have our dispatcher, we have the key. But we need two things. We need the start data. So at which timestamp do you want the volatility to start? All right, so let's say you want the volatility to start 1 month ago, then let's grab that information. So, okay, let's go back 1 month ago. We get the timestamp. So this is a pretty useful website, Epoch Converter, to just get go from human date to timestamp. I suggest you just go there if you need any timestamp. So let's grab this 1 month ago. No, 1 month ago. Then in the end, I don't know what Copilot is suggesting me, but all right. And now, so we want to compute the realized volatility of ETH between 1 month ago and right now. Funny enough, if you don't want to hard code this value, you can actually use the block timestamp. Actually, let's do this. So I think we need to do use darknet dash get block timestamp like this. All right. So it returned the U64. And so let's just grab this and fetch the timestamp. Okay, let timestamp equal get timestamp. All right. And so the start we want, so the end will be right, will be the timestamp, and the start will be the timestamp minus uh, minus 1 month, 1 month in milliseconds. So I need to do basic math. So I think 360, 360. Correct me if I'm wrong. It's quite late here, so don't really bother me. So we have 60 seconds in a minute, 100, no, in a minute, in 1 hour, day, and then 40. Okay.
Someone in the chat asking why are you all coding it? Is there any way to do it dynamically?
What are we talking about? Which part?
Yeah,
Yeah, too. Okay, I think that was
Yeah,
before I started to do it dynamically, I think, right?
exactly,
Yeah.
exactly.
So yeah, glad I answered in live. So yeah, indeed, you can do it dynamically using get block timestamp and using this value, I guess, if I'm good at math enough. But I think we get it. So now that we have the start, the end, the key, we're ready to yeah, we're ready to fetch it. So here it will actually be a summary stats dispatcher. So don't worry, you'll find everything into the template. Yeah, so that will be the summary stats dispatcher. We'll just need to go there and again, oh, import it right like this. And then let's get the volatility. So again, just following the documentation here. There's a volatility function. So volatility equals Oracle dispatcher get um, calculate volatility. Yeah, calculate volatility key start and end. And there is a last parameter here is the number of samples. So that is not like um, how to say, it's not that important. It's basically the number of yeah, the number of time you want to, number of samples you want. So in this formula, there is this n here. That's it. That's what you can code it. Yeah. So right now there is a maximum specified in the documentation of 200 for this impute. It's basically the higher this number, the more precise the computation will be. Yeah, so 100 is already quite precise. You can already have a quite precise result with that, but if you want, you can go up to 200. So we have a maximum of 200 um, because of Cairo steps limit. uh, Note that the steps limit will be increased. I think they increase is on a regular basis. So yeah, we can expect this number to go higher and higher as StarkNet matures and becomes more and more performant. All right, so we have everything here. It's all the code you need to fetch the volatility, and then yeah, and then be creative about what you want to do with the volatility. Really, I will put into the repo a lot of use cases of people using volatility or the data feeds in clever ways. Yeah, so unfortunately, the code that will put will be still in Caro Zero, but you can. It will. I hope it will give you still a source of inspiration. Yeah. So that's for the realized volatility. If you want to compute the mean, you can use the calculate mean. Again, that's yeah, that's quite useful if you want the mean. Feel free to come up with different aggregations or computational feeds. I would be very interested to see what you can come up with. As always, like don't forget that Caro is very powerful, right? If we're able to compute things like realized volatility, you cannot imagine what we could compute. So think about these complex computations that exist already in TradeFi and try to break them on chain and code them in Caro one. That's a very very valuable thing, I think, and you can start off with that, and then from this primitive you can think of products actually that will be built on top of this primitive. I think that's a very good way of seeing it. Okay, have we seen everything? We've seen how to get spot data, how to filter the sources, how to get realized volatility. Mm, in any way, the documentation is pretty self-explanatory. You'll find a bunch more information about how everything is computed, what each parameter means. So yeah, feel free to just go there, read all of the documentation, and feel free to ask any question. Every function is thoroughly documented there, so yeah, I think that's pretty useful. Maybe are there any questions before I jump into the um, yeah. Okay, so let's jump, finish by showcasing a bit what will come next. So as you can see right now, it's quite verbose, right? The interface is huge. Really, we have way too many functions. We have get spot median, get spot for sources, blah blah blah, and every time we want to add a new data type like future data, we need to redefine all of these functions again. Get future entry, future entries, future entries. Yeah, get entry. We're even adding options data, implied volatility feeds, notably, and we will need to redefine all of this function again. No, that's not definitely not something we want. So here is the new interface that will be live basically end of this month, next month. We're in the process of finishing the test and everything is fully open source, by the way. So if you want to come and contribute, here it is. All right, maybe here in the chat. But here is the Carol one rewrite. If you want to take a look, and it can also maybe help you in your Carol one journey. We've decided to rewrite it to take fully just take fully advantage of the new features that Caro one comes with. So options, enums, and generics. So now instead of having some get spot, get future, get option, get entry, you only have a one function, get data. And this get data function will take into account some expiry timestamp, which is an option just needed for futures and options data, and a data type enum. Here, you can specify the data type. I want spot data, I want future data, I want options data, and then the aggregation mode. All right, so that's how it's going to look like. And then for entries, you're going to have the generic type. Yeah, so that will be very powerful. We'll communicate a lot about that in the coming weeks. And if you're building something right now that leverages Pragma, you will be able to do the migration in a straightforward way. And it will actually reduce the amount of code that you write. So that's always a great thing. Okay, so maybe I can show like a small example actually of what it will look like. It will basically look like this. So instead of having to say get spot before, like, it was get spot median, here it will be get data. Get data, and you will be able to say, okay, and I want median reservation mode. And that's it. That's right. Dispatcher, get data, and data type dash dot spot colon spot. So, and if you want future, yeah, you can put future here. If you want option, okay, just put option here. But you don't have to change your call logic. And I think that's
Can you zoom a bit more? Someone asking in the chat.
Zoom a bit more on this.
Yeah.
Is it good?
Yeah, I think that's nice.
Yeah. So as I said, here is what it's going to look like. Way more powerful. Whereas before we have to redefine all of these functions. Now it's just changing one letter, one word, really. So yeah, really excited about this migration. Don't worry if you're coding right now for the hackathon. Just use this template. And yeah, the just changing when the migration will come up will be very simple for you. Okay. Do you see anything else, Edward, that I haven't talked about?
I think you covered pretty much everything that you can pull from the Pragma today. Yeah, I'm always like excited to see like if there's cool DeFi protocol coming out of like those computational feats. Because I guess like this is like also why using Pragma as well, especially on Starknet, is because you can pull and compute way more complex stuff like this, and also take advantage of that. So yeah, so I think like you covered everything. Um,
Yeah. So just let us know if you're building any DeFi protocol for or DeFi things, DeFi centric program for this hackathon. Just let us know. If you're building a new data feed or anything, we're really happy to help you in this journey. Head to the documentation. You will find everything you need there. You have the template. You have the documentation. I think you're well set for for building.
yeah, and of course, like feel free if you have any question, feel free to jump into the Telegram chat. I hope everyone is there. I will send it again here. Here's the Telegram Q&A chat. So feel free to jump there to ask your questions and do anything like not especially Pragma related but Hackathon related, and we will
Yep.
as well redirect you directly to the relevant person um, to help you to whatever you do.
And if you haven't yet, there is a form you can fill to just tell us what you're building, such that we can put the resources in place for you to just bring the right people to help you build what you want to build.
Yeah, awesome, awesome. Of course, like this is part of the hackathon of Pragma. Everything is found can be found on our TakeHype webpage. So if there are some outside listeners here on Twitch that lost themselves into that interesting workshop, here's a link. Everything you need to know about the hackathon is there, um, and yeah. So
So
yeah,
to wrap it up here.
I think we
Um,
can read it up. Is anyone still have questions? If no questions,
Perfect. And don't worry if you miss anything. All of this will be recorded on YouTube. Okay.
of course. Thanks everyone, and have a nice evening or a nice morning for some of you. And goodbye.
Yep. Thank you, everyone. Have a nice day, night. Bye.
Bye.